Well, let's bring in Paul Sutter, Leland Melvin, and Leroy Chow again. Thank you all for being here. And Leroy, wanted to ask you about this. With so many things that could potentially go wrong for a launch like this, what will NASA engineers be looking for before they do end up giving that green light in the days to come?
Of course, they're going to go through their procedures to detank the rocket, and then they'll start going in to inspect the engine number 3, and find out what valves are not working and why they were unable to get that preconditioning with the liquid hydrogen through the engine bell. The big question is whether or not they can fix this problem on the pad. If so, we could see another attempt on Friday. If they have to roll back to the VAB, the vertical assembly building, to remove the engine, then of course that we're looking at least, kind of the month's kind of delay.
And if you're just joining us, the news now that the launch of the Artemis-1 has been scrubbed for today, but there is an ongoing window, another opportunity coming up on Friday. Leland, wanted to ask you, the Artemis-1 mission, when it does happen, is all about testing new technology ahead of an actual crewed mission to the moon. Give us a sense of how much work has already gone into this.
Oh, it's been quite a bit of work. I mean, we talked earlier, this is 8.8 million pounds of thrust, the most thrust ever of a rocket going to space. And we're going to have, 4 people staying on board versus 3. It's much more space in the Orion capsule. We have so much more capability. We're launching, CubeSats to go around the moon and do experiments while we're up there. And so this new technology is going to help us go further than the moon and do deep space exploration, maybe to Mars one day. And I think this technology is going to be the game changer for us living and working on the moon, as well as going deeper in space.
CubeSats, it even sounds cool. And Paul, part of the new technology here are new materials that could better withstand the extreme conditions in space. Walk us through some of these breakthroughs.
Yeah, space and traveling in space is one of the harshest environments we can possibly travel through. We have to sustain the heat of the launch itself, which with a combustion of around 5,500 degrees Fahrenheit. We have to survive the frigid depths of space itself, and then we have to survive re-entry back into the atmosphere. And we've developed a lot of technologies with the Apollo missions, with the space shuttle missions. We learned a lot about tiling and thermal tiling with the space shuttle, of how to absorb the heat of re-entry. And unfortunately, some of those lessons cost some lives. And we've incorporated that technology into this new generation, again, hopefully to develop a sustainable presence in space where every generation that passes, we learn more and more, and we can do this easier and faster than ever before.
Yeah, reentry, very important, getting our people home. And it's a fun thing to Google if you want to, the advancements in technology that have come from space exploration. Paul, Leland, and Leroy, thank you so much this morning again for being here. Even though that Artemis-1 launch has been scrubbed, it is not canceled. We hope for that next chance on Friday.